In this lesson, we will talk about the sum of a sequence, and we can use the word series or partial sums to describe those. And we're also going to talk about sigma notation. Before we start, let's look at the graphs of three sequences, and which one would you describe as being convergent? So what does convergent and divergent mean? Well, here we have these points. The values of the sequence are getting closer to 0. And so we can say that the sequence is converging to 0. Here, these sequence values are going, looks like they're approaching 3. So we can say this converges to 3. But here we don't see that these don't look like they're approaching a number, so we say that's divergent. So this is convergent, convergent, and divergent. And now we have some more vocabulary. We can have a sequence and we can have the sum of the sequence, and that's called a series. We can have something, we could say S3. S3 is the third partial sum. And the third partial sum is the sum of the first three terms. So that would be 1 plus 2 plus 3. The third partial sum is 6. We could say S4. Well, that's the fourth partial sum. And that would be the sum of the first 4 terms. That would be 10. Then what can be a little confusing is sigma notation. So we could represent the third partial sum using sigma notation. And we say the sum from 1 to 3 of I is 1 plus 2 plus 3. The fourth partial sum would be the sum I equals 1 to 4, and that will be 1 plus 2 plus 3 plus 4. So we have to understand the different notations. We can also have a sequence of partial sums. And that would be the first, that would be S1, S2, S3, S4. S1 is 1. S2 is 1 plus 2. S3 is, or the third partial sum is 6. The fourth partial sum is 10. And we could continue, but it looks like there's a pattern. Plus 2, plus 3, plus 4, plus 5, plus 6. So that's a sequence of partial sums. Determine the convergence or divergence of the sequence. So here we're not talking about a sum, it's just a sequence, and we're going to look at what does it mean to converge or diverge. So we can make a table. And we're going to plug in a 1. So negative 3 times 1 plus 12 equals 9. Then we'll go negative 3 times 2 plus 12 equals 6. And 9, 6, 3, negative 3. Oops, it goes 3 at 4. We're going to have a 0. And we're just subtracting 3. Minus 3, minus 3, minus 3, minus 3, minus 3. So when we look at the graph, we can really see what's happening. At 1, we're at 9. At 2, we're at 6. 3, we're at 3. 4, we're at 0. Negative 3. And we can see that it's not going to converge, it's going to diverge. These numbers are going to negative infinity, and so we say that it diverges. These continue on to negative infinity, so that means it diverges. All right. Does this sequence converge or diverge? It's recursive, so make a table and find the terms of the sequence like we did in the previous lesson. Pause the video and try that one. And we know that A1 is 36 and A2 equals negative 1/2 A2 minus 1, which is negative 1/2. This is A1, negative 1/2 times 36, negative 18. And we can see that the recursive formula just says take a negative 1/2 of the previous term. For A3, we'll do negative 1/2 times negative 18. Then we'll go negative 1/2 times 9. Then we'll go negative 1/2 of that. And we can see that the denominator will continue to increase and the numerator stays 9. And that means this is approaching 0. And that means it converges. The sequence converges. If we look at a graph, at 1 we're at 36, at 2 we go to negative 18, at 3 it's at 9, then we have negative 4.5, and then we go to some positive number, and we can see that we're getting closer and closer to 0. So we see that it converges, the sequence converges. Okay, and here we're just going to substitute for n. Remember that this negative 1 to an odd power is negative 1. Negative 1 to an even power is positive 1. That creates an alternating sign. So make a table and see if it converges or diverges. Pause the video. So when n equals 1, we'll have negative 1 to the 1 times 1 over 4 times 1 plus 1. This will be negative 1, and that'll be a 5. Negative 1 squared times 2 over 4 times 2 plus 1. So that's a positive 2 over 9. Negative 1 cubed times 3 over 4 times 3 plus 1. Negative 3 over 13. And to see what we're getting close to, we should use decimals. So negative 1/5 is equal to negative 0.2, and this is equal to 0.2 repeating. This is equal to approximately negative 0.23 if we use the calculator. And when we put in a 4, we have approximately 0.23. These numbers would be different if we continued writing them, but it looks like we're approaching negative 0.23 and positive 0.23, and that's called oscillation, where we're just going to keep getting closer to two different numbers, and we'll call it oscillation. We say that this diverges due to oscillation. And we can see that in the graph. So at 1, we'll be at negative 0.2. At 2, we're at positive 0.222, and then we go to negative 0.3. Here we go to positive 0.3, and that just means we're going to be getting closer and closer to positive 0.23 and negative 0.23. So that diverges. So we have a sequence, and we can just do this with a table. So let's find the sequence values, and then we'll just add them, and we'll find the partial sums. We want the fourth partial sum. So when n is 1, we'll have negative 2 to the 1. That's negative 2 plus 3 is 1. Here we have negative 2 to the second power. That's 4 plus 3. Now we have n equals 3, so we put a 3 there. Negative 2 to the third is negative 8 plus 3, negative 5. Now we'll put a 4 there. We get positive 16 plus 3 is 19. And now we just add them up. The first partial sum is 1. The second partial sum is 1 plus 7. If we add all three of these, we'll have the third partial sum. And if we add all four of them, or just 19 plus 3 is 22. That's the fourth partial sum. And we could say that S4 equals 22. So make a table and find the third partial sum. That's 0.5 times the previous term. It's a recursive formula. Pause the video and try that. The first term is 8, and the next term is going to be 0.5 times the previous term. So we go 0.5, 0.5 times 8, 0.5 times 4. And we could just, for practice, we'll say, oh, the next term, 0.5 times 2. We only need the third partial sum. The first partial sum is 8. The second partial sum is 12. And the third partial sum is 14. So S3 is 14. Okay. So this will equal a number. That number is the partial sum. Then we can also, if we expand this, we can identify the terms of the sequence, and we can also write out the nth term. Remember that the nth term is also called the general form or the explicit form. This is called sigma notation, and that's Greek letter sigma. All we do is replace the n with a 1. So copy this, 4 times 1 minus 3. Copy it again, 4 times 2 minus 3. Keep copying this, and we just replace the n with the next value. We did 1, 2, 3, 4, 5. It said stop when you start at 1, you end at 5, and now we have, these will be the terms of the sequence. This is a summation notation, so that's why we're adding. This means add everything. And we have 4 minus 3, 8 minus 3, 12 minus 3, 16 minus 3, 20 minus 3. So we could say the partial sum is 5. Terms of sequence 1, 5, 9, 13, 17. And just, when you see the word sequence, you have numbers separated by commas. If you see a summation or a series, then you have addition instead of commas. So we have terms of a sequence. If we add them, now we have a partial sum. And we can also say that the nth term is 4n minus 3. Alright, pause the video and try the last one. 6n minus 3 over 2. And we just replaced n with numbers starting from 3 and ending at 7. 18 minus 3, 15 over 2. 24 minus 3. 30 minus 3. 36 minus 3. And 42 minus 3. We get 135 over 2, 67.5, and that is the partial sum. And we have terms of the sequence will be all of these: 15 over 2, 21 over 2, 27 over 2, and we can say that the sequence is, as a start, we can say that this is going to be wrong because this, if I say the sequence is 6n minus 3, that would mean we start with a 1. So we're not starting with a 1, and if we want to generate this as the first term, then we would just change the n to have it be n plus 2, 6, n plus 2 minus 3 over 2. Instead of doing that, let's modify it, because this sequence starts when n equals 3. So if I put a 1 here, it would give me 3 times 6 is 18 minus 3 is 15. So there was a little twist in that problem because it started with 3 instead of 1. That's the end of that lesson.